Hiya, welcome back. In this module, we're going to cover the basic concepts around AWS Lambda so that everybody's on the same page when we talk about operational patterns and practices later on in the course. To follow along with the demos in the module, you're going to need to have an AWS account. We will cover the basic anatomy of a Lambda function, including how functions are updated and versioned, and what each of the configurations mean. I will demonstrate these concepts by first creating a Lambda function from scratch in the management console and then deploying updates to it. But first, let's agree on our terminologies. When you're reading about AWS Lambda, you probably heard the term serverless an awful lot. Unfortunately, whenever you say that name, someone will remind you that there is still a server running somewhere. That is, of course, missing the point, since the servers are no longer a problem that you have to worry about. And technologies like AWS Lambda is serverless in the same way that Wi-Fi is wireless, even though there are still wires somewhere. Instead, the way to think about serverless is that it encompasses any technology that costs you nothing to run if no one is using it. You might have also heard AWS Lambda and other similar technologies described as function as a service or FaaS. The thing that separates function as a service from platform as a service offerings such as Google App Engine is that the unit of deployment and scaling is the function, as opposed to the application. Similarly, for container as a service offerings such as Amazon's ECS service, the unit of deployment is a container, and for infrastructure as a service, the unit of deployment is a virtual server. Whilst you can think of FaaS as a subset of serverless, which can consist of other services that meet the definition of costing you nothing to run if no one uses it. But by that same definition, some FaaS solutions such as Kubeless, which lets you run the function as a service on top of your Kubernetes cluster, should not really be considered serverless, since they're still paying for that Kubernetes cluster even when no one is using your system. Now that we've got the terminologies out of the way, let's talk about Lambda. To create the Lambda function, let's log into the management console. And from here, we can search for the Lambda service. And I also like to set up shortcuts for services that I use frequently. And this is the management console for the Lambda service. In the dashboard, you can see the total number of functions that you have in this region, as well as the total account level concurrency that you have. We will talk more about reserved concurrency later on in the course. You can also see account level wide metrics such as invocation errors, throttle invocations, invocation count, duration, as well as the number of concurrent executions. Let's go ahead and create a new function. Here you can see a bunch of blueprints. Some of them are very useful. For example, you may want to use a blueprint to help you get started with writing a Lambda function for Alexa skills. For now, let's create a function from scratch, and we'll call the function hello world. And we'll create a new role for this function from a template, and we'll call the role hello world role. And we don't really need to access anything, so we just stick with the test harness permissions for the IAM role. Let's create a function. Here you can see what AWS resources our function is able to access. For example, it's able to invoke functions in the account, create and write to CloudWatch logs, and to put items into DynamoDB tables. On the left, you can add event sources. For example, maybe you can configure an API gateway endpoint to our function, but we won't do that for now. It's worth noting that this is not a complete list of the available event sources to Lambda. And if you click on this IAM icon, you can also see the IAM role policy for the current execution role for the Lambda function. If you go back to the function's configuration, you can edit the code in line with the Cloud9 editor announced at reInvent this week. And you can choose what language to write your function in, which will also include Golang in the near future. Here, I can also test my code, but first, I need to configure what test payload I want to invoke my function with. Now, let's test. And you'll be able to see the output and logs from the invocation in the editor. If you scroll down, you can set the environment variables for your function and even have the key management service or KMS encrypt them for you. More on this later in the config management section of the course. You can add tags to your function so they can be more easily searchable. We already created a new IAM role earlier, and we discuss function permissions in more detail in the security section of the course. The most important setting for your function is the amount of memory you allocate and timeout. The maximum amount of memory you can allocate is 3 GB, and the more memory you allocate to the function, the more CPU power and the faster the function will run, but the more it will also cost you as well. More on this in the performance section of the course. Also, the maximum timeout you can set for a function is 5 minutes, and that's a hard limit. You can give your function access to VPCs, which we'll discuss in the VPC section of the course. For now, just remember that you should avoid giving your functions access to VPCs unless they really need it. For async event sources such as SNS and S3, you have the option to specify a dead letter queue where Lambda can forward events that cannot be processed even after 2 retries. Furthermore, you can enable active tracing, which allows Amazon's X-ray service to trace your function's invocation and report where the time is spent. We'll look at this in more detail in the X-ray section of the course. A brand new configuration that was announced at re:Invent is the ability to control the level of concurrency at a per function level, which allows you to specify for each function the maximum number of instances of this function that can be executing concurrently at any moment in time. And finally, as you can see from the message here, AWS also added the ability for CloudTrail to record every Lambda function invocation so they can be audited. If you go to the Monitoring tab, here you can see the same metrics we saw in the dashboard, but for just this function: invocation count, duration, errors, and throttle invocations over the last 24 hours. There is also iterator age, which is only relevant for Kinesis functions, and the number of dead letter queue errors, which is only relevant for functions with an asynchronous event source such as SNS, and the number of concurrent executions. Another new feature that was announced at re:Invent this week is the ability for you to zoom in into one of those metrics and then go straight to CloudWatch logs to see the logs for the time period that you have selected. And similarly, you can go straight to see the metrics for the function for that same time period. If you click on the Qualifiers tab, you can see we have an alias called the latest, which also shows up as the only version of this function. This latest version is special and is mutable. Whenever we edit the code or make any config changes and save, those changes will override the latest version. We can also take the current latest version of our function and create an immutable version by going to Actions and Publish New Version. As you can see from the warning message, since we are currently seeing the version 6 of our function is immutable, and therefore we have to go back to the latest version in order to edit our code. Let's change the result to hello from Manning, save, and test the function with the hello world payload again, and you can see the output reflects our change. We can also create a custom alias that points to a specific version of our function or to an existing alias. Another new feature that was announced at re:Invent is the ability to create a weighted alias that can shift traffic between 2 versions. We'll talk more about this feature in the Canary deployment section of the course. To recap, in this module we define the terms serverless and function as a service, or FaaS, and the difference between them. We cover the basic anatomy of a Lambda function, including how you can create a Lambda function in the management console, and the configurations available to you. We also looked at how you can test a Lambda function with the management console as well. Finally, we saw how you can publish a new version of your function and to create custom aliases that reference them. Later on in the course, we will also talk about the lifecycle of a Lambda function and what we mean by a cold start. We will cover cost considerations such as additional charges related to event sources and logging and monitoring. And we will talk about how the built-in retry behavior differs by event source and how it impacts you. But for the more immediate future, we are going to start building our demo apps shortly, an e-commerce site that's inspired by MulePal. First, let's familiarize you with the Serverless framework, which is a popular deployment framework for AWS Lambda, and we use it heavily throughout the rest of the course.